Hello, this is Ahmad Mirabi. I want to solve two questions about electricity, or the topic is about Coulomb's law and the electric field. Okay, let's read the question and solve it. I'll explain during the when I'm solving. Okay, two potential charges are brought closer together, increasing the force between them by a factor of 10. By what factor was their separation changed? The question meant us to express n2 over n equals r2 over r1, and the question says answer to two decimal places. Okay, so we want to solve this question. And the question is about Coulomb's law. Coulomb's law expresses that if we have 2 point charges, this is Q1 and Q2, and they are at a separation of R from each other, the force applied by these point charges equals to K Q1 Q2 over R squared. So this is a Coulomb's law. K is a constant, which is roughly 9 times 10 to the 9. Q1 and Q2 are point charges expressed in coulombs, and R is a distance expressed in meter, and F is force expressed in Newton. So in here, K and Q1 and Q2 are constant, and only R changes, and because R changes, F changes. So I'll write this formula 2 times and then divide them by each other to find R2 over R1. So I'll continue like this and say F1 equals K Q1 Q2 over R1 squared, and another time F2 equals K Q1 Q2 over R2 squared. Now we know that F2 over F1 is 10, because the question says increasing the force between them by a factor of 10. So I will simplify this expression to say that K Q1 Q2 over R2 squared over K Q1 Q2 over R1 squared will be equal to R1 over R2 squared. And this is given to be 10, so we can find that R2 over R1 equals 1 over radical 10. And if we calculate this, with a calculator, 10 radical and then the inverse of it, it will be roughly 0.32, because the question has said answer to 2 decimal places. Okay, so we need to get them closer to each other so that the force increases. So R2 over R1 must be a number less than 1, which is the case here. Okay, let's do another one. This time the question is saying what magnitude point charge creates a 4 kilonewton per coulomb electric field at a distance of 25 centimeter. Answer in nanocoulomb to a single decimal place. Okay, here it's a topic about electric field around a point charge. For example, if this is a positive point charge, there's some electric field around it, and if it's a point charge at any distance r from it, the electric field intensity is equal to kq over r squared. Of course, direction depends on the sign of the charge, but we don't have anything to do with the direction. We only need the magnitude, and in this formula, k is again a constant, which is 9 times 10 to the 9. Q is point charge, the magnitude of the point charge in coulombs. R is the distance in meter, and E is the electric field intensity in Newton per Coulomb. So I'll start solving by replacing the values. The E is given to be 14,000 because it is 14 kilonewton per second, kilonewton per Coulomb. K is 9 times 10 to the 9, and Q is being asked. R is 0.25 meter. 25 centimeter is 0.25 meter squared. Here I need a calculator to find Q. If I do it by calculator, 0.25 squared times 14,000 divided by 9 times 10 to the 9, I'll get a number which is 9.72 times 10 to the negative 8. Of course the units will be Coulomb, but here we need to express the answer in nanocoulomb. That's why I rewrite this in the form 97.2 times 10 to the negative 9 Coulomb, or 97.2 nanocoulomb. Now I've expressed the answer in nanocoulomb, and it has one decimal place. It has one decimal place in the answer. Okay, it's enough here. I just meant to solve some questions about Coulomb's law and electric field intensity.